Hey, it's Alex Williams, the New Stack, and this is a first for us. We're here at KubeCon plus CloudNativeCon, Open Source Summit China 2019 in Shanghai, and we wanted to start working on other ways to actually explain these complex technologies that we are finding so relevant for people who are building on Kubernetes or cloud-native architectures. And one way to do that is to actually show the technologies and discuss it. The context here is that we want to actually show and discuss it, not just with myself as a journalist who has enough knowledge to ask questions that are pertinent, but also with people who have been in the field for a while, have been developers or are developers, who can then ask questions of another technologist. So it becomes more of like a peer-to-peer demos of sorts. So today I'm glad to be joined by Patrick Donnelly, who's a developer with Red Hat, who's going to be explaining Rook. And Rook is an operator. It's used within the Kubernetes architecture. It's used to help orchestrate storage, correct?
Yes.
And we're joined by Cheryl Hung, who's been kind enough to join us. Hi, Cheryl.
Hey, Alex.
Thank you so much for joining us. Cheryl Hung is Director of Ecosystem for Cloud Native Computing Foundation. And so we're going to see a demo of Rook, the operator for Kubernetes architectures for storage. And the demonstration is going to be provided by Patrick. And Cheryl is going to be asking questions, and I'm going to be moderating. So let's get started.
Okay. Rook is an operator for Kubernetes that manages your storage for your Kubernetes cluster and makes it available in useful ways for your pods. The goal of Rook is to make storage as turnkey and as simple as possible for your Kubernetes clusters so that you don't need to worry about the details of how to, for example, set up a distributed storage system on your infrastructure. That's all taken care of for you by the logic that Rook provides. Rook being trying to put intelligence that normally is in your administrator's head and putting that into the cluster. That's the goal of an operator, and that's what Rook does. As for what I do, I'm actually a developer with the Ceph file system. I work at Red Hat and lead a team working on that project. I occasionally do work with the Rook team as far as how to get Ceph more integrated with Rook so that we can more easily deploy Ceph clusters in Kubernetes with Rook. But other than that, I actually don't do too much in my everyday development using Rook myself, as I usually deploy Ceph clusters on bare metal. But in the future, I expect I'll be doing more and more with Rook, even in day-to-day testing, deploying clusters with Rook.
Cheryl, Great. This speaks, doesn't it, to the discussions we're hearing a lot about how to manage state in many ways, doesn't it, in these Kubernetes architectures?
Right, yeah. So previously I was product manager at a storage startup called Storage OS. So it wasn't doing the same thing as Rook because it was more for block-based storage and for the database use case. But I'm quite familiar with the concepts behind why storage is difficult and why Kubernetes it's not been easy to manage storage in Kubernetes to date. And I think it's great that Rook, as a CNCF project, is coming in to help alleviate some of those challenges and make it easier to automate it.
So what's your first question? What is it do you really want to know?
So my perception of Rook is that it just automates Ceph. It automates the operations of Ceph.
Mm-hmm.
And so that's about the depth of knowledge I have about it. Where do you think that, from the perspective of a storage admin, why would they care about Rook?
Well, historically, there's two directions I can answer that question. I'll start with Ceph. Deploying Ceph and actually managing a Ceph cluster is known to be very challenging. That's from a usability perspective. Configuring a Ceph cluster is not the easiest thing to do.
Yeah.
And it's very easy to screw up in some way. Additionally, you have to deal with tasks like upgrading your Ceph cluster, and that usually requires a very detailed set of steps that you have to go through in order to actually do that. This requires a lot of careful administration on the operator's part. So one of the goals of Rook is to make that much simpler and put all that knowledge in the operators so that the person who's managing their Kubernetes cluster doesn't want to care about how to deal with Ceph. They don't need to know any of that.
Rook is you said it was a Kubernetes operator, right?
That's
so
right.
It is tightly integrated with Kubernetes. You
That's
don't
right.
ever use it outside of Kubernetes architecture.
I believe they're also trying to target other platforms, but I'm not too familiar with what.
But
how
Kubernetes
things have
primarily is our interest here for sure. Yeah.
Okay. So why don't you give us a bit of background about Ceph?
Okay. So Ceph is at its core a distributed object store. So an object store is similar to storing files on a disk, except with objects it usually has more featureful presentation of what kind of data you can store. For example, you could just store a blob of data, or Ceph also offers a key value store for your objects. And what makes Ceph great is that it distributes those objects across all of your devices, replicates them so you don't need to worry about redundancy, and handles failovers transparently. Go ahead.
No, you continue.
Okay. So on top of it, Ceph goes back to about 2005 when it was the original use case for the object storage that was being built was to actually provide a file system, and that was in response to needs from the national labs in the USA. What I work on every day is that file system, and the file system is put on top of the object store. So all of the files, all of the metadata for the file system is stored in that underlying distributed object store. So
Okay.
that's Ceph. Does that?
Yeah, I was going to ask you the kind of use cases and the because object and file
Sure.
are optimized for different things, but I think you've already kind of answered a little bit of it.
Right. So just to briefly touch into that, there's other access modes for Ceph, and the two other main ones is the block and the object. For block, you can set up a arbitrary block device of whatever size, and that is backed by that distributed object store in the same way as the file system. And on top of that, we provide certain features like snapshots and mirroring to ease usability, and that's all used. For example, the block device storage that Ceph provides, called RBD, is used heavily by lots of infrastructure projects like OpenStack, Cinder, and now with the advent of Rook and CSI, we're also using that for Kubernetes.
And CSI is the container storage interface.
That's right.
Cool.
Great.
Okay, so how about you show us a little bit of Rook?
Okay. So let's see. So Rook is, again, a storage operator, and it's meant to find storage in your cluster. That is, find devices that can be used for storage that are available, and given certain configurations that are set up by the cluster operator through the YAML descriptions of what the cluster's desired state should be, the Rook operator will go out and set up the cluster on the Kubernetes infrastructure, and that involves creating object storage device daemons. That's the individual daemons that manage the objects for a given device, like a SSD or a hard disk, and spin up the Ceph object storage daemons on those devices, and then also create the other Ceph daemons like the monitors, the manager, the metadata servers if you're using the file system, and distribute those across the cluster, and then finally bring up the Ceph cluster, do all the necessary configuration so that you can use it with your use it for Kubernetes, and then it will handle all the details of actually configuring the cluster for you.
So what are we looking at?
So this is an overview of the Rook architecture. To begin, on the left, we have the kubectl command, which is usually the entry point for doing anything in Kubernetes. And there you're going to define certain objects you want to set up that are at least related to Rook, and that might involve setting up your Ceph cluster or creating a file system, and that all goes through the Kubernetes API. The Rook operator on the very right will actually deal with the configuration of the pods for all the Ceph daemons and creating the storage classes, the persistent volumes for Ceph, and then actually go out to, having a Rook agent on all the nodes where Ceph may be deployed, actually spin up the daemons and the object storage devices, and that's on the bottom right.
Let me just pause there. So you mentioned the storage classes and the persistent volumes. So if I wanted more persistent volumes, then is that something that's configured when you start Rook, or does Rook pick it up over time? And presumably you have to have a way to add more persistent volumes if you need them.
My understanding, and I've not done this before myself, is you would need to you'd create those persistent volume claims and persistent volumes using the normal mechanisms, and then Rook will pick that up and actually talk to Ceph to get that done.
Okay, fine. Got it. Yep, keep going.
Okay. When you actually create a Ceph cluster with Rook, it's you have the usual YAML you write, or most of this is actually templated, and you can just copy and paste and change a few things. But in this example, we're creating a Ceph cluster that is running the latest version of Ceph, the Nautilus release version 14, and that's going to use those container images. And then we're defining how many monitors we want to run in the cluster. That'll be 3. The monitors in Ceph are used to maintain quorum about what the state of the Ceph cluster is, in terms of like what object storage devices are currently online and how many metadata servers there are, etc. And then finally, also that we want to use all of the nodes in the Kubernetes cluster for Ceph storage and running Ceph daemons. And so on the right, we have these various nodes, and we have 3 monitors distributed across the cluster and a number of OSDs. And Rook handles all those details.
I'm guessing if you don't want to use all nodes, then you would use labels.
Yeah, you could use labels to define where you want to deploy the daemons. In fact, I do that later on in my demo.
Cool.
Perfect. What's next?
So this is actually, I just deployed this OpenShift cluster, and the way OpenShift being the Red Hat flavor of Kubernetes, and I just deployed a series of virtual machines in this Linode cloud. Not to advertise for Linode, but one of the reasons I like using their cloud is I have a number of SSDs available on the virtual machines to use, and that's handy for spinning up Ceph clusters. So I have a number of, I think I have 7 virtual machines that I've installed. There's a master, there's infrastructure nodes, there's compute nodes, and an Etsy daemon all set aside for the Kubernetes cluster. And I've already run OpenShift Ansible on this, and the Kubernetes cluster is there and ready. So moving on to...
Could you just show us the nodes and so we can see how many worker nodes there are?
Yes, I'm going to do that. Cool. So if I do... So these are the nodes we have corresponding to those VMs.
Cool.
So now that we have a Kubernetes cluster available, the usual thing now, if we want to do a quick start of getting Rook set up, is we actually just use the example YAML files for how to do that. And the first step in actually deploying Rook is to start out by setting up this common set of YAML descriptions of various objects that Rook needs, and that includes setting up the namespace for Rook, and that's pretty simple and not very interesting. And then finally, we actually deploy this operator. I'm going to deploy this OpenShift version of the operator because it has certain security rules that are necessary for running the Rook within an OpenShift cluster instead of just a generic Kubernetes one. So that will run, and now we can actually look at what it's doing. I believe this is the right command. Maybe not.
What were you expecting?
I wanted to see oh, there they are. I had to change the project. So I wanted to see the various Rook pods that are running. So we have a number of Ceph agent pods. So these are just pods that run on all the nodes. There's 7 of them. And it's going to collect information about the machine that they're running on. In particular, it wants to know what devices are available for spawning object storage daemons on. The Rook operator is the brains of Rook, and it's just running anywhere, and it will actually talk to all the agents and figuring out where and how to deploy Ceph. Right now, we haven't actually configured a Ceph cluster yet. So right now, Rook is just spinning idle, not doing anything. Any questions so far?
No.
No?
It's fine.
Okay. The next thing we would want to do is create our cluster, and just to real quick look at the cluster YAML file. What I've done is I've actually set up an annotation for the node selector. We were talking about the labels. All of the VMs have been labeled in Kubernetes as having this label that I've created, saying that that the node can be used for storage. Otherwise, if you don't do that for my cluster, you need to have a number of I believe compute nodes available in order to deploy the Ceph cluster, where I want to fully utilize all my virtual machines. So I've labeled them all to be usable for storage. And we're also going to deploy a Mimic cluster. This is version
Is there
13.
a minimum number of nodes that you'd need?
If you'd want probably around 3 nodes at least, so that you can have 3 object storage daemons. Otherwise, Ceph won't be able to provide the guarantees you need for the redundancy of the storage, and certain things you'll see lots of health warnings or things won't work properly. So you want at least 3 nodes. And so here you can see the other information we talked about earlier, like the number of monitors that we want is 3, etc. I can go more into that if you'd like. Otherwise, we'll go ahead and start it.
Let's go. Yeah.
Okay. So we'll start this cluster. Now we'll watch it start. So the first thing Rook does is it goes and detects the version of the container for Ceph that it's planning to use. So you see this detect version pod that started. And that is just simply running Ceph version to figure out what it is.
What's the minimum?
Luminous version 12, but we're running Mimic, which is version 13. And so after it's done that, the next thing Rook's going to do is start up a monitor pod, or the first monitor that it wants to create for the cluster. And then as that completes, it's going to start more monitors until the number that we set as the desired count of 3 complete. You can see it's starting the second monitor now. This is probably the slowest part of starting up the cluster, but you only need to do this once, where we're just starting monitors and making sure we maintain quorum within the Ceph cluster, and Rook's handling those details for you.
So what's behind Rook? What is the architecture behind Rook that provides that kind of capability?
So Rook will be talking to the monitors periodically and using various Ceph commands to check that the quorum is being maintained. So all that logic is within Rook, and that's how it's doing that.
What's special about the Rook architecture then? What do you think is interesting about it?
What makes Rook special is that we're now being able to launch Ceph in a containerized way, and also in a hyper-converged fashion, so that all the daemons can safely run alongside each other, such that we have the resources configured properly, like the number of CPUs or RAM that a daemon should use, and that all the logic of actually deploying that is is maintained by an operator that's run continuously alongside Ceph. Normally, we would use something like Ansible or Puppet or some SSH orchestrator,
configuration,
to handle the deploying the Ceph cluster, and everything is just sort of done ad hoc in that fashion. But now with this operator, we have this continuously running helper that's making sure that the Ceph cluster is healthy and working properly.
Okay.
Cool.
So we can see the monitors have finished starting. Rook has also started the manager daemon. We only need one of those. I don't see the OSDs yet, and I don't know if that's because my demo is broken or it's just not started them yet. So let me start a toolbox. So there's this other container or pod that we can create.
Are these all templates then?
Yeah, these are all templates. So this is a useful template called Toolbox, which just creates a container that that you can SSH into to talk to the Ceph cluster. Due to various security policies within Kubernetes, it's not really possible to just SSH, or it's not advisable to just SSH into a monitor and start talking to that monitor. You're liable to shoot yourself in the foot. So we have this toolbox container where we can SSH into that. I was going to show get all. Show this toolbox. So we're going to SSH into that. Come on, tab complete. No. It was working earlier. Demos break everything.
Happens. Cool.
Okay, so we're in my toolbox, and now I can do Ceph status, and ironically, none of the OSDs were found, or there are no OSDs, but the health of the cluster is otherwise fine. The monitors have quorum, and the manager is active. I don't know why the OSDs haven't started. I just switched version from Nautilus to Mimic, hoping that I was going to avoid a problem I had, and of course that didn't. Now I have worse problems. The OSDs haven't started.
You mentioned before that Rook will monitor the health of the Ceph cluster. So is that right? Like it's running alongside, so it will monitor the health. So if there is an issue with the Ceph cluster, what does Rook do in that case? Like, does it output logs? Does it?
Yeah, there will be logs. I'm not a wizard enough with Rook to actually try to debug this on the fly right now. I would normally talk to my colleague Travis Nielsen, who works on the Rook project, to try to rescue me out of this situation. But
demos.
normally the problem is really trivial. What I'm doing right now is actually fairly unique. I'm deploying an OpenShift cluster in a virtual machine provider, and then trying to deploy Ceph on that, which is not, I'm pretty obscure, and nobody tests Rook like this, I think. So I find all sorts of weird issues that are particular to my configuration and setup. But yeah, so normally what you would do is look at the logs, and probably the problem is related to my node selectors are wrong, or I actually screwed up the configuration of my virtual machines and it doesn't know how to use those disks that I set up. So that's probably what just happened.
Kind of the story of new approaches, isn't it, too? I mean, it's there is a lot of there's a learning curve here.
Yeah, and it's my learning curve. I'm probably to blame why this doesn't work.
You never know until you try, right?
Yeah, that's right.
I mean, I've done many demos that have gone horribly wrong, so it's fine.
But Cheryl, I'm curious on your take on this. I mean, what's your final take on what we're looking at and what we've seen?
It seems straightforward enough, right? Like, that's the point of Kubernetes operators. They do abstract out a lot of the complexity. They also make it hard to debug when things go wrong. But in terms of like conceptually, it makes total sense. I know as well there are other options. Rook started out as an operator just for Ceph, but now you can do Minio, you can use Minio, and you can use some other file system that I've forgotten.
Cluster. Maybe cluster.
Okay. Yeah. So it's not just for Ceph as well. I do think it is valuable and useful, but it's sort of one piece of a toolkit, right? Like it doesn't feel like a full end-to-end solution at the moment. That's my impression.
Yeah, there's still quite a bit of work to do.
The configuration, right?
A lot of, I think the effort with Rook so far has been actually getting things working, but now they're sort of pivoting away towards let's actually make it usable and easy for operators to set up without much fuss, and then also be able to easily see when things go wrong. Like, for example, I've done something wrong, but
it's hard to see.
I think that would be a key thing to work on. If you're going to make it easy for non-storage admins to deploy storage, you also have to make it easy for them to understand why things go wrong.
Yeah, and I think part of that is even if we're trying to market a Kubernetes solution that involves Rook, a lot of these details of actually setting up the YAML files and the type of environment that you're deploying Kubernetes on will all be sort of statically defined, so that you don't run into these kind of problems that I'm experiencing because I'm doing things in a weird way.
But I think my impression is that if things go well, this is not actually just about Rook, this is kind of Kubernetes in general. If things go smoothly, it's great.
Yeah.
But if it doesn't go smoothly, like you actually need to know how Ceph works to be able to debug.
Yeah, if something does go wrong in Ceph, sometimes you will need to, have some Ceph knowledge to resolve it. In the ideal situation, you don't have to care. Similarly, if something with Rook goes wrong, you might need to actually look at some logs to figure out what was done wrong. And I think for that, you do need a little bit of Kubernetes know-how to kind of, get in there and debug what went wrong, which is not a skill set I really have.
This has been so excellent. I think this ending perspective is great because we can look at these technologies and say they're an operator for, for setting up storage in Kubernetes, but that's only the beginning. And the story takes a while to unfold, doesn't it? And you need to learn about these UI issues and, and the troubleshooting matters and all those types of issues that come up and how they get resolved is really the showing of the maturity of the project, isn't it?
Yeah, exactly. I mean, I think Rook is an incubating project within the CNCF, and I think
it was just promoted, I think, but yeah.
Yeah, I mean, but this is the nature of open source, right? Things are not always perfect, and you have to have a bit more technical knowledge sometimes to use them. But also a great thing about open source is people can contribute and start improving it.
You can go to your colleagues internally, but you could also go out to the community who are also building out Rook or who had experience with Rook to talk to them.
Yeah.
Yep.
Right. Well, thank you so much for your time, Patrick. Thank you for showing this demo. And Cheryl, thank you so much for asking very pertinent questions and helping us understand Rook and learning about a young project and how it works and thinking through the issues that it faces and how to move forward. So thank you for your time.
Thank you, Alex.
Thanks.
And Patrick.
Thank you, Patrick.
Great.